Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we have successfully finished the 8 lectures, right? So in a previous lecture that we have discussed about a resolution of vector in a two-dimensional plane. Okay, so whenever the vector is given in a two-dimensional plane, so what is the vector form of that given vector? So a bar is equals to ax I cap plus ay j cap. That is the vector form of given vector in two-dimensional plane. And what is the magnitude of that vector? Magnitude of a is equals to under root of ax square plus ay square. And what is the direction of the resultant vector from positive x-axis? Tan theta is equals to ay by ax. Okay. So and we are discussing the shortcuts to find the resolution of a vector in x direction and y direction. Also, we have solved some example problems, right? So all these things that we have discussed in a previous lecture. Okay, in this lecture today that we are going to discuss about rectangular components of a vector in three-dimensional or resolution of vector in three dimension. Okay, so and also we are going to discuss about direction, cosines, and the formulas. Okay, and two or three example problems are there. Okay, right. So this is about today's lecture. Okay, shall we start the session? Right. So my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Shall we start the session? Right. So what is the chapter going on? Motion in a plane. So this is a class number 09. Okay, right. So what is the concept today? So today's concept is what ma? Rectangular components of a vector in three dimension or resolution of vector in three dimension. So before going to discuss that, there is a small concept. Have a look. That is a Cartesian Cartesian form of a Cartesian form of a vector. Cartesian form of a vector. Have a look. What is the meaning of Cartesian form of a vector? So I'm taking a two dimension 2D, that means a plane. Okay, I'm taking a plane. So as we know, the plane consisting of two perpendicular axes. Let us say this is x-axis and this is y-axis. Okay, right. So we know that this is origin O. There is a vector called a bar is moving from origin O as shown in the figure, and this vector a bar is making an angle theta with the positive x-axis. Are you getting? Okay. Now I'm taking the magnitude of this a bar vector as a capital A. Okay. So magnitude of this a bar vector is equals to how much ma? Let us say capital A be the magnitude. And I'm taking the projection of this a bar vector. So the projection of a bar vector on x-axis as a ax bar. Ax bar is the projection of the vector a bar on x-axis. And the projection of the a bar vector on y-axis, let us say ay. Ay be the projection of the vector a bar on y-axis. Is it clear? Right. Now I want to represent the vector a bar. I want to write the equation for vector a bar. So that is a vector a bar is equals to, we can write ax bar plus ay bar. Ax bar plus ay bar. Are you getting? So in a previous lecture that we have discussed. So from the definition of unit vector, so here I am writing, have a look. What is the meaning of unit vector? A vector whose magnitude is said to be 1. A vector whose magnitude is said to be 1. Such type of vector is called what ma? Unit vector. So we know that in a rectangular coordinate system, in a three-dimensional coordinate system, this is x-axis, y-axis and the z-axis. So I cap is the unit vector along x-axis. I cap is the unit vector along x-axis, and j cap is the unit vector along the y-axis, and the k cap is the unit vector along z-axis. Already we have discussed. Have a look. Along x-axis, what is the unit vector? I cap. Along y-axis, what is the unit vector? J cap. Right. So we know that the formula of unit vector. What is the formula of unit vector? Let us consider capital A bar is a vector. A bar is a vector. And if you want to find the unit vector of this vector, then what is the formula? So A cap. So cap is the symbol for unit vector. So A cap is equals to, what is the formula? A bar by magnitude of A. Already we have discussed it enough. first lecture. Okay, in your first lecture we have discussed about a unit vector and its formula, right? So what is a unit vector? Unit vector a cap is equals to a bar by magnitude of a bar by magnitude of a. So from this equation, if you wanted to write the equation for a bar, if you wanted to write the equation for a bar, then we can write a bar is equals to a cap, a cap into magnitude of a cap into magnitude of a. So this is the equation for a bar vector from the definition of unit vector. Are you getting any doubts? Right. So what is a cap? A cap is nothing but unit vector. What is this? This is a magnitude of a bar vector, magnitude of a bar vector. Are you getting more? Right. So from this diagram, here we have ax bar. Here we have ax bar. Here we have what ma? Ax bar. So from this equation, I am going to write ax bar is equals to a cap into magnitude of a. What is a cap? A cap is nothing but unit vector. Have a look. Here ax bar is acting along a positive x-axis. Is acting along positive x-axis. And along positive x-axis, what is the unit vector? I cap. I cap is the unit vector. I cap into this magnitude of a bar vector. So here we have ax bar and its magnitude. I am taking its magnitude as ax. Okay. So finally we can write ax bar is equals to ax I cap. Ax bar is equals to what ma? Ax I cap. That means simply. So ax bar is nothing but the projection of a bar vector on x-axis. The projection of a bar vector on x-axis. Okay. So what is that? Ax bar is equals to ax I cap. So similarly, if you wanted to write a ay bar, so ay bar is equals to, we can write ay along y-axis. What is the unit vector? J cap. To write the equation for az bar is equals to az into k cap, az into k cap. So just substitute these values here. Okay. So have a look. So vector a bar is equals to, what is ax bar? Ax I cap plus ay j cap. Are you getting any doubts? Okay. So if you want to find the magnitude of a bar, so magnitude of a bar is equals to, we can write under root of coefficient of I cap square plus coefficient of j cap square. What is the coefficient of I cap? Ax. What is the coefficient of j cap? Ay whole square. So this is what magnitude of a bar vector. And if you wanted to find the direction from positive x-axis, it can be given by tan theta is equals to ax. Are you getting any doubts? Is it clear? Right. So in a three dimension, three dimension means what ma? Space. Okay, in a space. So I'm taking a three-dimensional coordinate system. So this is what? X-axis, y-axis, z-axis. Okay. What is the unit vector along x-axis? I cap. What is the unit vector along y-axis? J cap. What is the unit vector along z-axis? K cap. And what is this? Origin O. And from origin, there is a vector which is lying in a space. I am taking that vector as a bar. The component of a bar vector along x-axis, let us say ax bar. Along y-axis, ay bar. Along z-axis, its component is az bar. Are you getting any doubts? So same thing, na? So same thing here I am doing, but here we have only ax, ay. But here we have ax, ay, az. Okay. Bar is equals to ax bar plus ay bar plus az bar. Okay. So a bar is equals to, what is ax bar? From this equation we can write ax I cap plus ay j cap plus az k cap. So what is ax, ay, az? These are the magnitudes. What are those? Those are the magnitudes of ax bar vector. And what is ax bar? The projection of the a bar vector on x-axis. Ay bar is the projection of a bar vector on y-axis. Az is the projection of a bar vector on z-axis. Any problem? Right. So this is a bar vector in a given space. Okay, in three dimension. So if you wanted to find its magnitude, so the magnitude of a bar vector is equal to how much more? Ax square plus ay square plus az square. Ax square plus ay square plus az square. Any problem? Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Have a look. What they are asking? They are given the velocity of an object. Velocity of the object is given in a space. Space is nothing but what? In a 3 dimension. Is given by 3 meter per second along positive x-axis. The object is moving with 3 meter per second velocity along positive x-axis and 6 meter per second along negative y-axis. 6 meter per second along negative x-axis and 8 meter per second along z-axis, positive z-axis. What they are asking? Find the velocity vector of the object. We have to find velocity vector of that object. Have a look. Solution. So as we know, this is x-axis, y-axis, z-axis. Okay. So I cap is the unit vector along x-axis, and j cap is the unit vector along y-axis, and k cap is the unit vector along z-axis. So the velocity of an object in a space is given by 3 meter per second along plus x-axis, positive x-axis. That means the object is moving towards positive x-axis with a speed. Velocity of the object along x-axis is equal to how much more? 3 meter per second. And a 6 meter per second along negative y-axis. Along negative y-axis. If this is positive y-axis, then this is what more? Negative y-axis. And what is the unit vector along negative y-axis? Minus j cap. What is the velocity of the object along negative y direction? 6 meter per second. Are you getting any doubts? Okay. So 8 meter per second along positive z-axis. Along positive z-axis, the velocity of the object is equal to how much more? 8 meter per second. We have to represent this information is in the form of vector. So in general, so what is the vector a bar? In general, vector a bar is nothing but what ma? Ax I cap plus ay j cap plus az k cap. So this is the form of a vector in 3 dimension. So here we have vector a bar, but in a given question, they are given vector v bar, velocity. They are given what ma? Velocity. So a is nothing but what? V bar is equals to vx I cap plus vy j cap plus vz k cap. That's it. हो गया. So v bar vector is equals to what is vx? Vx is equals to 3, and this velocity is along positive x-axis. Then its unit vector is I cap. What is vy? 6 meter per second plus 6 meter per second. What is its direction? Along negative y direction. Along negative y direction. What is its unit vector? Minus j cap plus vz. Along positive z direction. What is the velocity? 8. Along positive z direction. What is its unit vector? K cap. Therefore, the velocity vector v bar is given by 3 I cap plus into minus 6 j cap plus 8 k cap. So this is the equation for velocity vector from given question. Is it clear? Any doubts? Right. So if you wanted to find the magnitude, of a velocity, magnitude of v bar vector is equals to 3 square plus 6 square plus 8 square. Okay. So 3 square 9, 6 6 are 36 plus 8 8 are 64 under root. So 64 plus 36, 100, 100 plus 9, 109. So this is the magnitude of the velocity vector. How much more? Under root 109. Any doubts? Is it clear? Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So let us discuss about rectangular components of a vector in 3 dimension or resolution of vector in 3 dimension. Have a look. So what is the concept? Rectangular components of a vector in 3 dimension or resolution of vectors in 3 dimension. Okay, right. Have a look. I'm taking a 3 dimensional coordinate system. I'm taking the 3 dimensional coordinate system. As you know, this is what x-axis, okay, y-axis, and this is what z-axis. Okay, right. So what is the unit vector along x-axis? I cap is the unit vector along x-axis, and j cap is the unit vector along y-axis, and k cap is the unit vector along z-axis. Okay, sir, right, sir. What is this? This is origin. Go. Now, I'm considering the vector a bar. I'm taking the vector a bar from the origin. I'm taking the vector a bar from the origin. Let us consider this is a vector a bar and which is passes through an origin. This is a bar vector. Okay. Any doubts? And considering the magnitude of this a bar vector as a capital A. So what is capital A? Capital A is the magnitude of this vector a bar. How much? Capital A. Have a look. The vector VO A bar. The vector VO A bar is equals to how much? It represents capital A bar. Is it clear? Any doubts? OA is nothing but what? A bar vector. And what is capital A here? Where capital A is nothing but the magnitude of the A bar vector. The projection of this A bar vector, the projection of this A bar vector on x-axis, the projection of A bar vector on x-axis, I am considering AX. AX is what? The projection of, what is AX? The projection of A bar vector on x-axis and down. I'm taking the projection of A bar vector on y-axis as a AY. AY is the projection of A bar vector on y-axis. And I'm taking the projection of A bar vector on z-axis. On z-axis is AZ. Okay. So have a look. This is the direction of AX vector, and this is the direction of AY vector, and this is what? The direction of AZ vector. Is it clear? Any doubts? Right. So now I'm just going to draw a parallelopiped from point A from point A with its three edges passing through x comma y comma z axes. So I'm just drawing a parallelepiped from point A. Its edges must be passes through x comma y comma z axes. Have a look. So this is a point A. So from the point A, I'm going to draw the parallelepiped. Okay. Right. To get a proper diagram, I'm just extending this AY y-axis. Okay. So this is y. This is what? AY. And the unit vector is j cap. Okay. So now a rectangular parallelepiped is formed. A rectangular parallelepiped is formed. Okay, have a look. I'm just going to give the name for this parallelepiped. This is O. This is a point A. Okay, and this is what? This is a point B. And I'm taking this is a point C. Okay, and this is a point D. And this is a point E. This is what? Point E. Okay, so O, A, B, C, D, E is the name for parallelepiped. Okay, are you getting any doubts? Right. So I'm just taking one more vector, that is OE. Okay, so OE is the one more vector we have taken. So from figure it is clear that this A bar vector is a diagonal for the parallelepiped. Have a look. So A bar vector is what? So diagonal for the parallelepiped. Okay. So from figure, A bar vector is a diagonal for what? Parallelepiped. Okay. Right. So from figure, according to parallelogram law. So according to parallelogram law, this is a vector OE. This is what? OE vector. And this is what? Vector OA bar. And this is what? EA vector. This is a straight line actually. But why I am calling it as a EA vector? Have a look. In a parallelepiped, two opposite sides are same. This side OC is equals to what? EA. This side OC is equals to what? EA. Then OC is equals to AY. Then EA is also becomes what? AY, because they are parallel sides. They are what? Parallel sides. Have a look. The direction of OC is in upward direction. Then the direction of EA is also in upward direction. So from this figure, it is clear that the side or the vector OC bar is equals to what? EA bar. Okay, EA bar. So have a look. Its direction is in upward direction. Its direction is what, ma? Upward direction. So have a look. O A E. This is O, and its direction is this, and this is EA. This is what, EA, and this is the direction of OE. So this is the direction of OE, and this is the direction of EA, and this is what, OA. Have a look. OE and EA both are in order. OE and EA both are in order, and OA is in reverse order. Then we can write OE plus EA. OE plus EA is equals to, we can write OA. Can we write like this by using parallelogram law? So these two vectors are what, ma? In order. Then the resultant is given by the closing side of the third vector, which must be taken in reverse order. So we can write like this. Is it clear? Right. So I'm using one more diagram. So from figure, have a look. This is OD. This is what? OD. OD vector. So what are these? These are the vectors now. Okay. Right. OD. This is the direction of OD, and this is the direction of OB. And have a look. This is what? OE. This is what? OE. So this is the direction of OD vector, and this is the direction of OB vector. And the resultant of these two vectors and the resultant of these two vectors is given by what? OE. Are you getting? Are you getting? Right. So this is OD and this is OB. Then the resultant is given by OE. So we can write from this diagram. From this diagram, we can write from diagram a diagram, this diagram. Okay, from this diagram we can write OD plus OB is equals to, then the resultant is given by OE. Say this is equation number 2. What are these? These are the vectors. These are what? These are vectors. Are you getting any doubts? Okay. So I'm just substituting equation 2 in 1. I'm just substituting equation 2 in 1. Okay. So OE. OE is equals to what, ma? So just substitute OE value here. So what is OE? I'm going to rub this one. Okay. Right. If we substitute OE value here, so OA is equals to, we will get OA bar is equals to EA bar, EA bar plus, what is OE? OE is nothing but OD bar plus OB bar. OD bar plus OB bar. Okay. Any doubts? Any doubts? Right. So have a look from this diagram. From this diagram, it is clear that OA. What is OA vector? OA bar is nothing but A bar. Okay, sir. What is EA? EA is nothing but what? So the vector EA bar is equals to, the vector EA bar is equals to the vector OC bar, because these two are the opposite side or the parallel sides. So OC bar is equals to, what is the vector? What is the vector along OC side? That is AY j cap. So vector OC bar is equals to what, ma? AY j cap. I am directly writing in a vector form. Okay. So vector A bar is equals to its magnitude into unit vector. Its magnitude into unit vector. Next, what is OD? OD bar is equals to O D bar is equals to what, ma? AZ K cap. AZ K cap. Next, OB bar. So OB bar is equals to what? OB bar is equals to AX I cap. So just substitute all these things in this equation. Okay. So let us say equation number 3. Therefore, what is OA bar? OA bar is nothing but A bar, that is equals to, what is EA bar? EA bar is nothing but AY j cap plus OD bar. What is OD bar? AZ K cap plus OB bar. What is OB bar? AX I cap. I'm just rewriting this equation as A bar is equals to AX I cap plus AY j cap plus AZ K cap. So if you want to find the magnitude, right. So if you want to find the magnitude of A bar vector, so magnitude of A bar vector is equals to under root of AX square plus ay square plus az square. So this is called what? The rectangular components of a vector in three dimension or resolution of vectors in three dimension. Okay, did you understood? Any doubt? Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So let us we discuss about the next concept, that is a direction cosines. Okay. So the concept is what now? Direction cosines. Okay. Right. What is the meaning of direction cosines? Have a look. Again, I'm taking a three-dimensional coordinate system. Okay. X-axis. This is a y-axis. This is what? Z-axis. Okay. So in this coordinate system, from the origin, I'm taking a vector a bar. I'm taking the vector a bar. Okay. So let us consider the magnitude of this vector a bar is, let us say, magnitude of a. So this is what magnitude of the a bar vector. Now let us consider this a bar vector. This a bar vector is making an angle alpha with the x-axis. A bar vector is making an angle alpha with the x-axis and angle beta with the y-axis, angle beta with the y-axis, and angle gamma with the z-axis. Angle gamma with the z-axis. Have a look. With respect to x-axis, alpha. With respect to y-axis, beta. With respect to z-axis, gamma. These are the angles made by a bar vector with x, y, z axes. So, what is the meaning of direction cosine? Have a look. The direction of the direction of the cosine of angle made by given vector made by given vector. So in this coordinate system, what is the given vector? A bar is the given vector with x comma y and z axes. X comma y and z axes is given by is given by. So the direction of the cosine of the angle made by given vector with x comma y comma z axis is given by so cos alpha, cos beta, cos gamma is equals to is equals to is equals to. Okay. So what is the formula? Have a look. As we know that the projection of this a bar vector on x-axis is what ma? Ax. The projection of this a bar vector on y-axis is what ma? Ay. The projection of this a bar vector on z-axis is what? Az. Are you getting? Right? And just writing the formula for cos alpha, cos beta, cos gamma for direction cosines. So cos alpha is equals to ax by magnitude of a. So the direction of the cosine of the angle made by this a bar vector with x-axis is how much? Ax by magnitude of a. What is Ax? The magnitude of the component of a bar vector on x-axis. Okay. So Ax by magnitude of a. So magnitude of a bar. So cos beta is equals to, we can write Ay by magnitude of a, because this a bar vector is making an angle beta with the y-axis, and this is the magnitude of a bar vector on y-axis. That is Ay divided by magnitude of a. Next, Az divided by magnitude of A. Cos gamma is equal to Az by magnitude of A. Okay now. So what is Az? The magnitude of the A bar vector on z-axis, and angle made by a bar vector with the z-axis is how much? Gamma, beta, alpha. Are you getting? So in a simple terms, in a simple way. So what is the cos theta in general? What is cos theta? No? Adjacent side by hypotenuse. Adjacent side by hypotenuse. If you take cos alpha, so have a look. This is a cos alpha. Here alpha is there. Okay. So cos alpha is equals to 1. Adjacent side by hypotenuse. Adjacent side by hypotenuse. What is adjacent side? Ax. What is hypotenuse? Magnitude of A. Okay. So cos beta. Adjacent side. Ay. What is hypotenuse? Magnitude of A. Are you getting? Cos gamma. Adjacent side. Along theta side. Az. Divided by hypotenuse. Magnitude of A. Are you getting? Any doubts? So these are called what? Direction cosines. These are what? So these are called the direction cosines. Okay. Let's have a look. And just writing the formulas. So the first formula, not number one. Okay, have a look. So cos square alpha plus cos square beta plus cos square gamma. Cos square alpha plus cos square beta plus cos square gamma is equal to, we can write ax square divided by magnitude of a square plus ay square divided by magnitude of a square plus az square divided by magnitude of a square. Okay, have a look here. All the denominators are same. All the denominators are same. Then we can add the numerator. So that is equals to, we can write ax square plus ay square plus az square divided by magnitude of a square. Are you getting? Okay. So what is ax square plus ay square plus az square? What is ax square plus ay square plus az square? In general, we can write the a bar vector as a ax I cap plus ay j cap plus az k cap, right? So if you want to find the magnitude, it becomes under root of coefficient of I cap square plus coefficient of j cap square plus coefficient of z cap square. So have a look and just squaring on either side. So magnitude of a square is equals to square root. Get cancelled out and you will get ax square plus ay square plus az square. Now ax square plus ay square plus az square is equals to what now? Magnitude of a square, that is equals to magnitude of a square divided by magnitude of a square. So magnitude of a square get cancelled out and we get cos square alpha plus cos square beta plus cos square gamma is equals to how much ma? 1. So remember this formula, important formula. We have problem on this formula. Okay. So the sum of the direction cosines of the given vector in a space is equals to how much? 1. The sum of the direction cosines of the vector in a given space, 3 dimension, is equals to how much? 1. So not number 2. Have a look. Right, not number 2. So what we got? Cos square alpha plus cos square beta plus cos square gamma is equals to 1, right? Okay. So we can write, already we know that sin square theta plus cos square theta is equals to how much? 1. This we can write cos square theta is equals to 1 minus sin square theta. Cos square theta is equals to what? 1 minus sin square theta. We can write like this. So cos square alpha is nothing but what? 1 minus sin square alpha. Cos square beta is nothing but what? 1 minus sin square beta. Cos square gamma is nothing but 1 minus sin square gamma. Just substituting this formula here. So we will get 1 minus sin square alpha plus 1 minus sin square beta plus 1 minus sin square gamma is equals to 1. Okay, I'm just substituted this formula here. So 1 plus 1 plus 1, you will get 3 minus sin square alpha minus sin square beta minus sin square gamma is equals to 1. Okay, so 3 minus, I'm just taking minus common, so you will get sin square alpha plus sin square beta plus sin square gamma is equals to 1. So send this minus of sin square alpha plus sin square beta plus sin square gamma to that side, it becomes plus, and bring this 1 to this side, so plus 1 comes to this side, it becomes minus 1. So 3 plus 1 comes to this side, it becomes minus 1. That is equal to, if minus term went to that side, it becomes sin square alpha plus sin square beta plus sin square gamma. Okay. So finally we got sin square alpha plus sin square beta plus sin square gamma is equal to how much? 3 minus 1, 2. So this is also one of the important formula. Okay. So note these two formulas. These two are important formulas. We have a problems on these formulas. Okay. Are you getting any doubt? So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So let us see the example problems. So the example number 1. So find the direction cosines of a vector a bar is equals to 3 comma 4. So what they are asking? They are asking to find the direction cosines of this vector a bar. So they are given components. What are those? 3 comma 4. What is 3 comma 4? Solution. 3 comma 4 is nothing but the component of x-axis of a bar and the component of a bar vector along y-axis. So the vector form of a bar is given by, already we have discussed, what is that form? Ax I cap plus ay j cap. So the vector form of a bar is equals to, what is the value of ax? 3 I cap plus what is the value of ay? 4 j cap. Okay. So what they are asking? They are asking direction cosines. So we know the formula for direction cosines. What is the formula? So cos alpha is equals to ax by magnitude of a, and cos beta is equals to ay by magnitude of a. Are you getting any doubts? We have the values of ax and ay. What we have to find? We have to find the magnitude of a. So we have a bar vector. From this a bar vector, we can find out magnitude of a bar. That is equals to under root of coefficient of I cap square plus coefficient of j cap square. So that is equals to root over 3 3 is a 9 plus 4 4 is a 16. 16 plus 9, 25. Root over 25 means what, ma? 5. So magnitude of a value is how much? 5. Are you getting any doubts? I just substitute here. So cos alpha is equals to, we got, what is the value of ax? 3 divided by, what is the value of magnitude of a? 5. Then cos beta is equals to, what is the value of ay? Value of ay is 4 divided by magnitude of a is equals to how much, ma? 5. Okay. So in a 3 4 5 triangle, I told you that. So this 3 by 5, this 3 by 5 can be written in terms of cos is cos 53 degrees. Are you getting? What is the value of cos 53? Cos 53, 3 by 5. So cos get cancelled out and alpha is equals to 53 degrees. That means whatever the vector a bar they are given, this a bar vector is making an angle 53 degrees with the x-axis. Alpha is what? The angle made by the given a bar vector with x-axis. Okay. So we are written in diagram now. Okay. So a bar vector is at a 50 degrees from positive x-axis. So if you comes to here, so cos beta is equals to, what is the value of 4 by 5 in terms of cos? So cos 37. Cos 37 value is how much? 4 by 5. So cos get cancelled out and beta is equals to how much, ma? So beta is equals to 37 degrees. That means whatever the vector a bar given, that given vector is making an angle 37 degrees with the y-axis. With the y-axis. Are you getting any doubts? So these are the direction cosines, and these are the angle made by a bar vector with x and y-axis. Is it clear? Any doubts? Right. So let us see this example. What they are given. Find a bar vector if its length is 26 and direction cosine is cos alpha is equals to 5 by 13 and cos beta is equals to minus 12 by 13. What they are asking? They are asking vector a bar vector is equals to how much they are asking. Okay. Solution. Have a look. What is the a bar vector? A bar vector is equals to ax I cap plus ay j cap. Okay. They are given its length. Length is equals to 26 meters. That means magnitude of a bar given how much, ma? 26. Are you getting any doubts? Okay. What we have to find? We have to find this a bar vector. That means we have to find the values of ax and ay. Is it clear? We know the magnitude of a bar vector. How much? 26. They are given. Okay. So also they are given what? Cos alpha. So what is the value of cos alpha? Cos alpha is equals to 5 by 13 and cos beta is given. What is cos beta? Minus 12 by 13. Are you getting any doubts? This is we have to find this information they are given. Okay, right. What is cos alpha? Cos alpha is nothing but what, ma? Ax by magnitude of a, that is equals to 5 by 13. Cos alpha means ax by magnitude of a. Cos beta means what, ma? Ay by magnitude of a, that is equals to minus 12 by 13. What is the value of ax? We have to find. So ax divided by magnitude of a is equals to how much? 26. That is equals to 5 by 13. Okay. So ay, we don't know. We have to find what is the magnitude of a. 26. That is equals to minus 12 by 13. Okay. So 31 is 13, 32 is 26. 13 1 is 13, 13 2 is 26. If 2 went to this side, 2 5 is 10. So ax is equals to, we get 10. The value of ax is equal to how much, mark? 10. So similarly, if ay is equals to, if 2 went to this side, 12 2 is 24 minus 24. Just substitute in this equation. So therefore, the vector a bar is equals to ax I cap plus ay j cap. What is the value of ax, mark? What is the value of ax? 10 I cap plus what is the value of ay? Minus is there. Minus into plus minus 24 JK. That's it. Any difficulty is there? Simple problems, okay? Right. Right. Have a look. The third example they are given. So a bird moves with a velocity of 20 meter per second. A bird is moves with a velocity of 20 meter per second in a direction making 60 degrees with the eastern. With respect to eastern direction, it is making how much mark? 60 degrees. And 60 degrees with the vertical upward direction. And 60 degrees with the vertical upward direction represent the velocity vector in rectangular form. What they're asking? They're asking to represent the velocity vector in rectangular form. What is the meaning of velocity vector in rectangular form? Solution. Have a look. V bar is equal to V cos alpha I cap plus V cos beta j cap plus V cos gamma k cap. So this is the velocity vector in rectangular form. So what is that? V bar is equals to V cos alpha I cap plus V cos beta j cap plus V cos gamma k cap. So already we have find the formula for direction cosines in cos terms. What is that? So cos square alpha plus cos square beta plus cos square gamma is equals to how much? 1 is equals to how much? 1. So what they are given? A bird moves with a velocity of 20 meter per second. They are given the value of v. What is the value of v? 20 meter per second. Okay, sir. Let's have a look. In a direction making 30 degrees with the eastern line. Right, have a look. From this condition, it is clear that they are given the velocity of the bird is making 60 degrees with the eastern direction. So the velocity vector is making an angle 60 degrees with the eastern direction. So that means alpha given. Okay, and it is making 60 degrees with the vertical line. 60 degrees with the vertical line. So this velocity vector is making 60 degrees with vertical direction. That means beta value also they are given 60 degrees, but we don't know gamma. We have to find it. Have a look. So I'm substituting 60 degrees at alpha, 60 degrees at a beta. So cos square 60 degrees plus cos square 60 degrees plus I don't know cos square gamma I have to find is equals to 1. So what is the value of cos 60? 1 by 2. But here cos having square, so cos square that means 1 by 2 whole square plus here also cos 60 1 by 2 whole square. I don't know cos square gamma is equals to 1. So 1 by 4 plus 1 by 4 1 by 2 whole square means what? 1 by 4. 1 by 2 whole square means 1 by 4 plus cos square gamma is equals to 1. So 1 plus 1, 2 by 4 plus cos square gamma is equals to 1. So 2 ones are 2 2s are. So cos square gamma is equals to 1. If 1 by 2 went to that side, it becomes minus 1 by 2. 1 minus 1 by 2. Full minus half. You will get half cos square gamma is equals to 1 by 2. Are you getting any doubts? So pause the video and write this answer. Pause the video and write this answer. 3, 2, 1, go. Cos square gamma is equals to 1 by 2. If square went to that side, it becomes root cos gamma is equals to 1 by root 2. So 1 by root 2 can be written as cos gamma is equals to cos of 45 degrees. Cos 45 is equals to how much? 1 by root 2. So cos get cancelled out and the gamma is equals to how much? 45 degrees. So alpha they are given how much? 60 degrees. Beta they are given how much? 60 degrees. Okay, magnitude of velocity, how much? 20 meter per second. Just substitute all these values, all these values in V bar vector, in V bar vector. So what is V bar vector? So in rectangular form, the velocity vector is equals to V cos alpha I cap plus V cos beta j cap plus V cos gamma k cap. Okay, are you able to see the board? Okay, sir. Then V bar is equals to V cos alpha I cap. What is the value of V? 20 cos what is alpha? 60 degrees I cap plus V 20 cos beta cos 60 degrees j cap plus V 20 cos gamma cos 45 j cap. And just substituted the values of alpha, beta, gamma and V in this equation. So we got V bar is equals to 20 into cos 60. What is the value of cos 60? 1 by 2 I cap plus 20 into cos 60 again 1 by 2 j cap plus 20 into cos 45 1 by root 2 take out 1 by root 2 take out. Are you getting any doubts? Right, 2 ones are 2 tens are 2 ones are 2 tens are. If it comes to this term, 20 can be written as 2 into 10 divided by root 2. Okay, so that is equals to 2 can be written as root 2 into 10 divided by root 2. So root 2 get cancelled out. So 20 by root 2 means what, ma? Root 2 into 10. Root 2 into 10. Are you getting? Okay. So V bar is equals to 10 I cap plus 10 J cap plus root 2 10 K cap. Root 2 10. Okay, root 2 10 K cap. So this is the required answer. Okay, so the velocity vector in the form of rectangular components. What is that? Just remember any vector in terms of rectangular components. So v bar is equals to what, mark? So v cos alpha I cap plus v cos beta j cap plus v cos gamma j cap. So we have the formula cos square alpha plus cos square beta plus cos square gamma is equals to 1. So they are given alpha beta values. Okay, eastern means x-axis, vertical means y-axis. We don't know the value of gamma z-axis. Okay, angle made by velocity vector with z-axis. We don't know. We have to find. So from this condition, I substituted alpha beta values and I find gamma value. So after finding the gamma value, just to substitute all these values in this equation, we will get the answer. Is it clear? Any doubts? Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So this is the end of the today's lecture. I hope that you have understood what is the Cartesian form of a vector. Okay. So resolution of vectors in 3 dimension or rectangular components of the vector in 3D and direction cosine. How to find the given vector in rectangular form and problems. Okay. I hope that you are understood. So we will meet on a next lecture. And this is Rakesh signing off. Jai Hind.